researchers at Tampere University have successfully developed a novel optical fiber design allowing the generation of rainbow laser light in the molecular fingerprint electromagnetic region. This new optical fiber with a self-cleaned beam can help in developing applications to, for example, tagging pollutants, cancer diagnostics, environmental monitoring, and food control. The finding was published in the journal Nature Communications. When taken to the extreme, such interactions can lead to the generation of a rainbow laser of light, commonly referred to as a supercontinuum light source. Since its first demonstration in a special type of optical fiber in 2000, supercontinuum laser light has revolutionized many areas of science, ranging from metrology and imaging at unprecedented resolution to ultra-broadband remote sensing and even the detection of exoplanets. Extension of supercontinuum light to other wavelength regimes such the mid-infrared requires optical fibers made of so-called soft glasses, but these possess a lower damage threshold than silica, limiting even more the power of the supercontinuum beam. Non-silica optical fiber with a self-cleaned beam. Recently, a different type of optical fiber with a refractive index that varies continuously across the fiber structure has been shown to yield a dramatic increase in supercontinuum power, while still preserving a smooth beam intensity profile. This leads to a self-cleaning mechanism that yields supercontinuum light with high power and a clean beam profile. As well as their many applications, they also provide a means of studying fundamental physics effects such as wave turbulence, says Professor Gauri Genti, the leader of the research group at Tampere University. While these fibers have recently attracted significant attention from the research community, their use has been, up to now, restricted to the visible and near-infrared. In collaboration with the group of Profs. This problem has now been solved by using a particular design that utilizes two types of lead-bismuth gallic glass rods with different refractive indices drawn to yield a nanostructured core. The result is a graded index fiber with an effective parabolic refractive index profile with transmission up to the mid-infrared, and, as cherry on the cake, enhanced nonlinear light-matter interactions, says researcher Zara Aslami. Great potential in diagnostics and monitoring. The mid-infrared is of crucial interest as it contains the characteristic vibrational transitions of many important molecules. The novel solution will lead to more efficient supercontinuum light sources in the mid-infrared with many potential applications e.g. for pollutant tagging, cancer diagnostics, machine vision, environmental monitoring, quality and food control, explains Genti. The research was carried out at Tampere University and within the Academy of Finland Flagship for Photonics Research and Innovation, PREIN. Make a difference. Sponsored Opportunity Story Source. Materials provided by Tampere University. Note. Content may be edited for style and length. Journal reference. Zara Aslami, Lori Salmela, Adam Filipkovsky, Dariusz Pish, Mariusz Klimczak, Ryszard Baczynski, John M. Dudley, Gauri Genti. New self-cleaning optical fiber can help in monitoring environment and diagnosing cancer. Science Daily, the 22nd of April 2022. ift.tt/isonmpd. New self-cleaning optical fiber can help in monitoring environment and diagnosing cancer. Science Daily, ift.tt/isonmpd. Accessed April 22, 2022. Thanks for watching. Please subscribe my channel for more videos.